Hello friends, today I will be discussing about an interesting work. The work was published in Nature Communication Journal in this year by Kathy Rabon and Nichols group from Sweden. They reported that reaction between benzamide and morpholin in presence of phenyliodine diacetate and potassium phosphate under heating condition can lead the formation of hydrazide. It's a dehydrogenated nitrogen-nitrogen coupling reaction in presence of hypervalent iodine reagent. The authors have synthesized a series of compounds using different primary as well as secondary amines. And as per the proposed mechanism by authors, benzamide reacts with this phenyliodine diacetate reagent to form iodinium intermediate with the loss of acetic acid. Now, this amine coordinates to this iodinium intermediate to get this amide amine iodinium intermediate, which undergoes reductive elimination of iodobenzene to produce this hydrazide product. This paper was published on March 26, 2024, but the authors retracted this paper on June 18, 2024. The authors were made aware about an error of product characterization. That means the authors failed to recognize the correct product. Now, I will be discussing what is the correct product. Before discussing about the correct structure, quickly I will show three literature. These earlier reports are about hypervalent iodine chemistry of primary amides. You can see primary amide reacted with hypervalent iodine reagents and generated isocyanate intermediate by rearrangement process. Now these isocyanates are reactive towards nucleophile. It can react with alcohol to form carbamates. Urea moiety can be generated by using amine as the nucleophile. Now this amine might be primary amine, secondary amine, aliphatic as well as aromatic. So common thing is that isocyanate intermediate has been formed from amide under hypervalent iodine condition. Now in the Nature Communication paperwork also, they have used benzamide under hypervalent iodine condition, but they did not mention formation of any isocyanate intermediate. Maybe that's why these three literature are not cited also. Opel and Paturo group were also not convinced about the claim structure in Nature Communication Journal. They wanted to reproduce the result. What they did, they performed one exactly identical reaction in between benzamide and morpholin using the same reagent condition and isolated some compound. At the same time, they have followed one well-known literature method to synthesize this urea derivative 1B from the reaction between phenyl isocyanate and morpholin. Now they have recorded NMR spectra for both these compounds individually. What they identified, both these compounds are giving exactly identical NMR spectra. One more thing they did, they mixed these two compounds in equal quantity, then recorded NMR spectra and seen it is giving only one set of spectral lines in NMR. So they predicted that there is high possibility of this compound to be urea product. And the final confirmation they achieved with the help of X-ray crystallographic analysis. Similarly, they have performed one more reaction and the compound structure was confirmed with the X-ray crystallographic analysis that correct structure for this reaction is urea product, not the hydrazide. The error about product identification could have been avoided. It could be done by NMR matching with the earlier reported compound spectra. For example, you can see for both molecules there is a significant difference in peak position, although the spectra were recorded in same solvent. Now, one interesting fact you can see in this slide, the authors retracted their Nature Communication paper in June 2024 after they were informed about the incorrect structure. The investigation work was published in Chemistry and European Journal in July 2024. Right after this publication, the same authors, Kathiraban and Nichols, published the result from the reaction between benzamide and amine in Molecules Journal by correcting the structure. This paper appeared online in November 2024. However, they did not mention anything about their earlier Nature Communication paper. Here on left side picture, I have shown the product structure they reported in earlier paper from reaction between benzamide and primary amine, and in right side picture the corrected structure of the product from the same reaction. Here as well you can see the corrected structure of the product from reaction using secondary amine as the nucleophile. Here also you can see the corrected structure for the compounds from the reaction using morpholine and thiomorpholine as the nucleophile. Drug related products also, whatever they have reported earlier as hydrazide products, in the current Molecules Journal they have presented as the urea derivatives with the corrected structure. One more thing I found by comparing supporting information data from both paper, the spectral data what they have used for the earlier Nature Communication paper for any particular compound, the same identical spectra has been used for the publication in Molecules Journal. Here I have shown one example. You can see these two spectra are exactly same spectra, and not only for one compound, all the compounds they have reused the earlier spectra for the current publication. Here is example for one more compound. You can see the earlier published spectra has been reused for the current publication. The fact is that most of the publication policy says the reuse of any content from already published article is not allowed without giving proper credit to the original source. If you have any different view, please let me know. Thanks.